Write each rational expression in simplest form. Our first example, we have 49x squared over 35x. 49 you can write as factors 7 times 7. X squared is x times x. 35 you can write as 7 times 5, and we have a single x. Now, you don't always have to go through these factoring and canceling. You can just simply reduce 49 over 35 if you like. You can cancel the common factors of 7 and a common factor of x. That will leave 7x over 5 as your final answer. Now, if you want to bypass writing out the factor style like this, what you would do is you could take 49 over 35, divide both numbers by 7, and that would give you 7 and 5 respectively. When you divide the same variable, you subtract their exponents. 2 minus 1 is 1. The middle example, 24 over 80. If you write with factors, 24 is 8 times 3, 80 is 8 times 10. Y squared, that's a couple of y's multiplied. Y to the fourth, that's 4 y's multiplied. Canceling common factors, you cancel the 8's and a couple of y's. That leaves you with 3/10. And there are 2 y's left over in the denominator. Notice back in the original problem, if you subtract exponents, y to the fourth minus 2 is y squared, but there's more in the denominator, so that's where the leftovers go. The upper right example, 42 minus 7x, you can factor out a 7, and that will leave 6 minus x as the remaining terms. 42 divided by 7 is 6. Negative 7x divided by 7 is negative x. Subtraction can't be just simply turned around like addition can. Addition you can turn around because 1 plus 5 is the same as 5 plus 1. But it's not true with subtraction. There is a way around it, though. There's a loophole. If you need to turn around subtraction, go ahead and turn your terms around, reverse their order, but you have to compensate with a negative sign. So that's what's highlighted in blue, is I turn 6 minus x around to x minus 6. That way I can cancel it with the factor from the denominator, but I have to have that negative sign there to maintain proper signs. Our next example, we have x squared minus 49 over 7 minus x. This is going to be very similar to the one we just did. X squared minus 49 is a difference of 2 squares. Take the square root of x squared, you get x's. Take the square root of 49, you get 7's. Alternate with a plus and a minus sign. The denominator is real close to canceling with x minus 7. So let's turn it around. Remember, if you turn around subtraction, compensate with a negative. Now you can cancel your x minus 7's, and that leaves negative x plus 7. Our example to the right, x squared plus 6x minus 7, that's a trinomial. You can factor that as long as you can come up with a pair of numbers that'll add up to 6 and multiply out to negative 7. In class, you guys told me to use a positive 7 and a negative 1, and that gets it done. 7 plus negative 1 is 6. 7 times negative 1 is negative 7. In the denominator, we have another trinomial. We can find a pair of numbers that adds up to 9 and multiplies out to 14. You guys told me to use 7 and 2, both positive. If you add those, you have a sum of 9. Multiply, you get a product of 14. That shows us that there's some x plus 7's we can cancel because there's common factors in the numerator and denominator. Whatever you don't cancel makes up your final answer. Let me remind you, I reminded you in class, don't cancel these x's because they're attached to numerical values with a plus and a minus sign. If these are multiplied like 1x over 2x, then you can cancel the x's. But if adding and subtracting is involved, you either cancel it all or don't cancel at all. Our final example, x squared plus 6x minus 16. This is pretty much a repeat type of problem from the last example. In the numerator, we have x squared plus 6x minus 16. We can factor with 8 and negative 2. 8 and negative 2 have a sum of 6 and a product of negative 16. In the denominator, we can factor with x plus 3, x plus 8. 3 and 8 have a sum of 11 and a product of 24. We notice that there's common factors of x plus 8 in the numerator and denominator, so cancel those out. Your remaining factors are x minus 2 on top, x plus 3 on bottom.